G'day, I'm Graham. I'm one of the full-time makers here at Core Electronics, and while I founded this business back in 2007, a lot has changed since. We find ourselves helping with maker needs for retail, for learning how to code something, to how to build a circuit, connecting people with solutions from a couple of different angles, and that maker spirit throughout that whole process is something that I really enjoy as a lifestyle. Throughout that lifestyle, we find ourselves providing workshops, whether they're here at Core Electronics or they're at schools, at events, in workplaces. And I particularly want to share with you today what I feel is the Maker Invention Cycle that works very well for us, and I hope it does for you as well in the educational environment. Now, the Maker Invention Cycle is something that's more of a theme-based experience for building projects and initiating and continuing a project from start to finish. So let me give you some examples of what students have come up with in a recent workshop. Here we have a guitar. So this guitar powers up and you've got capacitive touch chords, LEDs and some sound. And over here we have a harp, and this harp is much the same. And if I power this up, we've got the circuit playground in the middle. We've got some capacitive touch strings that make their way around. And if I was to interact with these, the circuit playground responds to my interaction with it. This project as a whole, fantastic. There's so many layers baked into this process, from team building to ideation to coding, building, adding some dazzle. And let's deconstruct this a little bit and have a look at how all of this is possible. So to kick off, let's have a look at the cycle that I'm referring to. That is the Maker Invention Cycle. So here it is. It kicks off with theme. Now, when you're inventing stuff, there's just so many choices. If you ask every team to come up with something that they feel passionate about, or they just want to make that day, limitless. And maybe you can do that. You can have a freestyle type environment. But I find there's a lot more value in the cohesion of the whole experience if there's some sort of connected theme arcing all this together. For example, superhero accessories or musical instruments, which we'll do today. It could be anything that creates a bit of a narrower set of ideas, but still really helps people come up with an idea, something they feel that's possible and achievable, and to explore like common or shared experiences of challenges and how they overcome them throughout that process. So theming is up to the educator. Theming is something that is you get a feel of your students, of the environment, and what you've done before, and what you feel would be well suited. Intro. So the next part of this is to introduce new hardware. So today we're going to have a look at the Circuit Playground Express, but you might be using another board. It might be Microbit, Raspberry Pi, Arduino. If it's electronics and there's coding involved, then usually some sort of onboarding experience is essential to explain what's possible with this board. And even some examples are like images and videos that other people have made things with. Chances are students have experienced some type of technology like this in the past and have a feel for what's possible. So you might even be able to help just celebrate the new features of a dev board that you're working with. So that's the intro. If I was doing that with little bits or something, I'd be talking about inputs and outputs. If I was doing that with something more complicated like an Arduino, there'd be some like examples, like basic circuits involved, what it can do and it can't do. If it's something like the Circuit Playground, a bit more of an exploration of what's on this board, because there are a ton of features on this board, and it will help with the ideation process when people break into teams. So when you break into teams, when we get people to break into teams, it's 2 to 3 people per team. So you're looking at building a team that has great diversity. Someone that's great at coding, someone that's great at structure, and someone that's great at like creativity. Bring those traits together, and you're going to have a very great dynamic throughout that process. Sometimes strengths tend to link together, so all the coders get together because they're familiar with each other. But encourage that diversity to happen across that team base. When you're in the teams, that's when we actually start coming up with ideas of what will work for this invention cycle. So in the case of today, we'll do musical instruments. So if I was looking for somebody in a team, I'd be looking for someone that has great creativity and great engineering or just structural type ideas. And I would be the coder in that group. So teams are where the ideas are had, where the people come together. Lock down a project name, give the team a name. The team comes up with their own name. And this is where you start really forming that sense of alignment to the narrative that is the invention cycle. From there, let's start making this possible. There's always two places you can start when it comes to a project like this. Do you start with code or do you start with structure? I feel that starting with code helps introduce the challenges a lot more quickly, particularly when you're working with something like this, where the majority of the hardware is all on the one board. This really brings out the ability to start getting into code immediately and going through and visualizing on the computer how this is going to work from a functional perspective. So you get the teams exploring the features that they want to work on, how touch will work. Use simulation before you get into the expensive part of the project, that is building the project. We're not just talking about educational costs here of consuming cardboard and bits and pieces of equipment, but we're talking about the real world dynamics of product design. You definitely want to make sure that you've got that invention well seated from a practical point of view and something that can be sustainably implemented. So from there, build. That's the part of the project where you start building the structure of the thing. So you've now got your dev board on board. You've simulated this from a functional point of view on the PC, and now you're about to start building this out, this design, this thing that you've made. If I look at this example here, I can see some structure material like this cardboard. And we've put a hole through it. We've got the microbit on the side, and we're starting to see this structure come together. Now, this part of the build process, I would recommend just focus on the structure first, like the minimum viable product to get something functional. And then once it's functional, switch into Dazzle. So Dazzle is where you come back and you add all the color, the splash of color, all the extra bits and pieces that you think will help make this project just stand out from the crowd. Really personalize it and make it your own. And of course, at the end of that cycle, you want to share it. So teams, get up there, have a chat about what they've made, demonstrate how it works, and that's where the magic really happens. They've owned this process from right back here. Because share is, I've linked share to theme, which basically means keep in mind the things that you've done in the past or the experiences that students have had in the past that might help curate a better outcome for the next theme, the next time you go down this invention cycle. And with that in mind, students actually are a part of this whole process, from ideation through to creating to sharing it with their peers. It's a recipe for success for a really great project-based experience. And let's build something today. How about like a grand piano or something? Let's explore how complicated ideas can be built with fun tech and lead to really creative outcomes. So let's kick off from the top. I'm going to approach this as I am a maker. You as an educator, I hope you can deconstruct this process in a way that is empowering to your own experiences in the classroom, that really do align very well to the STEM activities that you encourage and probably have similar ones, week in, month out, within your school. So let's kick off with theme. First of all, we know this is a workshop. Students are pre-baked to that idea. Today's theme for the workshop is going to be musical instruments. I'd start a discussion around musical instruments that we could build today and seed the idea of ideation across the whole group. Now, after that discussion and some buy-in over that process, move into the intro of what we're going to work with today. I'm going to be using the Circuit Playground. So the Circuit Playground is a circular development board, and it is just jammed packed with technology. So here's a large version of the Circuit Playground. Before I kick on too far, it's worth noting there are two types of Circuit Playground. Circuit Playground Classic, which is like the original product that Lee Moore from Adafruit came up with. And then there's the Circuit Playground Express. That's the one which is this one, which is much easier to interface with, to program. When you connect by USB, it presents as a USB drive. You just drag and drop over your code. It will reboot and then run your code. It's just so pleasant to use. Let's have a little look around the Circuit Playground Express. I'll start at the top and just make my way through each of these features as I see them. So we have the micro USB jack at the top. That's for connecting your USB cable for programming and power from a PC. You could, if I jump down to the bottom, use the battery connector, which is this little guy here. And that's a JST connector that's common with LiPo batteries and little AA battery packs. Very easy to find, and it means that the battery pack allows this device to operate on the go. You could use it anywhere in the classroom. You don't have to have USB connected. From there, you have an interfaceable LED on pin 13, which just turns on and off. A non-interfaceable LED on the other side, which is for power. It indicates if power is available on the board. We have the technical stuff, our flash, memory, and the microcontroller. You can't do a lot with those other than they're used for everything on the board. However, the SAMD21 chip that's on here, great little chip. It allows the Circuit Playground Express to hold a lot of code to present as a USB drive when you plug it into a computer, and then there's no programmer or any drivers that are needed on. So whether you're using a Mac or a PC, it will just work like a USB drive, and you can drag and drop your files onto it. Coming back to the board, we have the light sensor, a left button, a right button. Up the top here, a temperature sensor. In the middle, we have a reset button, which just resets the board and begins running the code again, handy for debugging and just having a look at how things work. An infrared transmitter, an infrared receiver. So this could be for it's the same way your TV remote works, that you could actually send information from one circuit playground to another circuit playground. Or you could learn the controls from another remote controller and then use those controls to interface with this board. Right in the middle, we have the motion sensor. So the motion sensor is a XYZ accelerometer. It'll know what's happening to the board from a motion point of view. And if it is in a rested position, then it knows which way gravity is affecting the board. So if I had it sitting flat like this, then only the Z axis would be affected by gravity. If I turned it this way, then only the Y axis would be affected by gravity. Somewhere in the middle, and I'll get half on both. That's great info, and it can lead to a lot of very interesting projects. Moving down, we have a slide switch, which is interfaceable. You can write code that will detect where that position of the slide switch is. You have a speaker and a microphone, so you can both sense sound and you can emit sound. Now, this speaker isn't a buzzer; it's actually a speaker. So you can create tones of frequency that represent different signals, modulated signals. Now you can't play like a high definition MP3 files through here. Well, you sort of can, but it absolutely works fine from a tone generation point of view and adds so much more value than just a buzzer alone. And you just simply cannot miss the NeoPixels that run around the outside. NeoPixel is the trade name for the WS2812 LED. So these are red, green, blue LEDs, very popular in the maker industry. They are individually addressable, and you can control the red, green, and blue elements of them to create any color in the rainbow. And around the outside, we have alligator-friendly connection points for all of our inputs and outputs. So there are 14 pads in total. You even have an analog output, so you can create analog signals from this device, which is, if you're familiar with Arduino and some other dev boards, that's a big deal. Like being able to create an analog signal to do other things, while not necessarily engageable for young learners, as time goes by, a great feature to have on a dev board. So the mix as a whole, from capacitive touch to digital inputs and outputs to analog outputs, red, green, blue LEDs, sound in and out, light in and out, motion and temperature. It's a one-stop shop for learning to code and getting on with the inventive cycle. Now from here, I'd probably show some students some projects that have been done in the past. And a great resource for that is going over to MakeCode. So you can go to MakeCode, click on the Circuit Playground Express, and on the page that loads, while you can start your own project and begin doing things, you can actually go down and have a look at other projects that people have created in the past. Maybe you've bookmarked a couple that you'd like to share with students in particular. And if you're wondering how any of this works, they're quite well documented. So it's a nice little lean in for ideas and even for yourself as an educator to stay 1 foot in front of that process. This has got you covered. Now we're up to the teams part of this. I'm the only guy in the room today. While you're watching this, or everybody's watching this through the event, I'm here on my own, and I'm going to be the team. I would identify as the coder in the group. So I would be great with software, and I would be looking for someone that's great with structure and someone that's great with creativity. Now I'm going to have to wear all of those hats today, but the idea of forming into a team is to get that diversity of people to help encourage like a better experience for every team that's participating in this experience. So I've got to give myself a team name, and let's just go with Team Maker for today. As for our team's idea, I think a grand piano is a great place to start. If it feels like an impossible outcome, and as an educator, you might be like, students come up with a great idea, seemingly impossible, but there's always a way forward within the constraints of what you've got and how the creative process unfolds. So the last part of the team step is to draw the thing that you want to come up with. It's important that everybody shares the vision of what we're going to create, work within the constraints of what we have, and this is one of the first moments that you're working through the constraints of what's possible. But it doesn't often affect the creative process. So I'm going to do my best. Again, I'm the coder. I'm not the creative guy. I'm going to do my best though to draw the grand piano that I'd like to make today, and let's see what happens. Okay, quite possibly the worst drawing of a grand piano. However, this is the circuit playground. This is some capacitive tape going down to my keys. These are my keys for my grand piano. This is the general structure and shape of how I intend this to work. I might have some challenges here as I bring the tape around this edge and getting it right down to these points here. The type of materials and the folds that I'll use that I've got available here. Like I would like to have like a bit of a negative cavity on this side of it, where I've got the feet on the back, sort of prop up the back of the piano. I could have definitely done with some help from somebody that had better drawing skills, but this is our team's project, my team's project. Team Maker are going to build a grand piano today, and let's get on with it. The next part of the creative process, coding. So our team has a general idea of what this project is, what we need to do with the circuit playground to make this work. We're going to have some of these inputs will be used for capacitive touch. We're going to use the speaker, and I'd like to have some color as a part of that process as well to indicate what tones are being pressed, so I get both an audible and a visual response to my interactions with this piano. Now, I can do all of this from the PC. I don't need to get tied up in breadboarding or anything like that. So head over to makecode.com. You don't need an account or anything, and I'm sure for most of you, you've explored MakeCode at some stage. This is an experience based around the Adafruit Circuit Playground, and what makes it a little bit different than the microbit is that it has the ability to produce RGB color around the outsides here with these RGB LEDs. It can both sense sound and emit sound. The majority of the other stuff is quite same, but you don't have a wireless radio in here. That is a bit of a game changer for the microbit. You do have the infrared transmit and receive, which is quite good for projects where you have other devices talking to each other, depending on the complexity of the project and the things that you're doing. That's a handy feature. But today, inside MakeCode, let's have a look at how the Circuit Playground Express works. Now, I'm sure you've seen programming at this level 100 times before. So let's just build a very quick demonstration of how to simulate a project in this environment. We have our forever loop. I'm going to add in some logic. So let's bring in a if this then that. And for the condition, I'll introduce an input, and let's go with button A. So I've chosen button A, and is pressed is the expression. And so when button A is pressed, let's create some music. So let's grab a play sound budding and drop that in there. Now I could change the sound that that is emitted, but for now let's keep this really straightforward as a proof of concept. If I had audio connected to my PC, which I don't, so that we don't accidentally get audio coming through into the video, now that I've created this circuit, I could interact with this button, and I'll get a speaker response when I do this project. In addition to that, I'm going to add some LEDs to this. So let's go over to light, and I'll bring maybe an animation. That sounds fun. Let's drop the animation in there as well. So it'll play a sound and then show a rainbow animation. We could change this from animation to one of the other pre-baked experiences, or we could custom build an animation from start to finish using the custom tools in the light blocks. You may have noticed or not that the circuit playground over here on the left was gray for a moment, and then it became full color. Well, full color in the sense that it wasn't just black and white. The reason why it goes black and white is because it's preparing the simulation. So if I was to stop the previous simulation and then begin again, press the play button, we're now ready to simulate this project. So now when I press, this is the equivalent of connecting power to your circuit playground. So now that I've connected power, I can press the A button, and if I had the speaker connected, you would have heard the speaker, heard the ding, but you could absolutely see that the LEDs had some sort of an effect. I'll do that again, and you can see that the LEDs, the rainbow effect only runs for so long, and then it stops. So I could do this for, I could quickly make a change to say 2 seconds for the animation. And now when it's reloaded that program because I've made a change. It went black and white for a moment. Now it's back to full color. And now when I press the A button, I'll get this animation for a full 2 seconds. That simulation process, gold. That's how the real world works. You have an idea about a thing, you simulate and you explore how to build that thing from a proof of concept point of view. And then you're ready to get into the real world. You can start building the structure and making the thing that you've set out to achieve. So now we're up to the build phase of this project. And I've got some tips on how to make this a lot easier in big groups. So we break things up into tools, structure, and dazzle. The tools are the scissors, the color, the tape, double-sided tape, gold for projects like this. Magic tape, awesome because it, when you remove it, it doesn't leave a lot of residue. Glue can be a bit iffy depending on the time that you have to hold things down. Tape is probably a lot faster from a educational experience point of view. Your copper tape, invaluable for projects like this. It allows you to get capacitive touch, which doesn't require a return circuit. It can just run straight out, and if you touch it anywhere, that could be registered as an input. And it also lets you run resistive circuits as well, so circuits that actually run through an LED, power it, and run back to another system. So really handy for like electrical, curious projects. And then we have our structure. So we have our cardboard, can be colored and just pretty simple stuff. And I've got with me today a packing box. It could be just recycled cardboard, things that you've got from around the house or around the classroom. But I'm going to use just a packing box and for my structure. And I recommend you keep separate. Like the dazzle is the second last part of the project. Add all your color, your bobby eyes, the bits and pieces that adds shine and the fine trim of the project. Save all that for the very end because it is a bit of a loose end on how long you can spend adding dazzle to a project, and it's a great little way to make sure that all the teams can really get something done in that timeline, and then add the dazzle to the end. The teams that just excelled through the code and build can absorb that time with adding the dazzle to the project, And the teams that just got there in the end will be able to add some quick bits and pieces to their project in preparation to share it with everybody. So let's prep this. So I've got my big piece of cardboard. I'm going to cut this down a little bit and make it a bit more manageable for this project. Now, students will run into challenges like what I just did right now. I may not have observed it as a student, but I definitely would have been overwhelmed having this massive piece of cardboard on the desk and trying to do something practical with it. So this is an opportunity to inject some tips here and there along the way, and to offer some guidance on how you could practically deliver or build this thing. I find a handy way to work with cardboard or structural stuff is to draw the picture that you want to cut out. In this case, I have my sketch of the grand piano, and so I'm just going to get the basic structure, the bones of this project together, and then let the rest of it sort of come together as I go. As I'm building this, I see an opportunity on these edges to create these edges here. I might be able to use tabs that come down. I'm a little bit concerned that I won't be able to get like a flush edge all the way around. But if I just have tabs that run down, I can put some cardboard over the top of that later and conceal that space. This is a pretty complex build. It's not just a flat surface. I've gone with a 3-dimensional thing. But I'll try some ideas in this first design and see how they go. The special part to this, though, is that I'm communicating it. I'm hitting this challenge on how to design this 3-dimensional object. If I was in a team, we'd be hitting this journey together. We'd be exploring ideas and coming up with solutions. You'll be able to see the tension form or the friction point of an idea that might seem inaccessible. That's a great opportunity to enter as a third party and help that team with some suggestions that will get them over the line. And you'll find with a little bit of encouragement, anything's possible. Rocket ships, cars, grand pianos, there's always a way forward. Now, it looks a little bit complicated. I have some methods to my madness here. I'd like to fold, this being the top surface, I'd like to fold this particular section so it's vertical, and then this bottom section so it's flat again. These side parts come down and form the front legs, because I'd like the piano for something to be able to sit at the piano, and the knees go underneath, and it just looks like a piano. This is actually where the keys go on this bottom panel. So we'll have the keys will sort of take that whole line, and we'll have some copper tape coming down to that surface. I've added tabs around each of the main corner points, so I can hopefully follow the curve of that top surface. But let's cut it out and have a look at how it comes together for what is adding the second dimension to this project, which is the height factor and overcoming some of the challenges along the way. So it's not a grand piano just yet, but let's see if some of my ideas have panned out for the long run. So each of these tabs can fold down. We'll have the front part of this project. I just want to make sure I bend it in the right spot. Yep. So that's the front part of the piano, and then I want to bend in the opposite direction, the part underneath for the keyboard itself. Great. So that's worked out quite well. Now I have my front legs for the piano, and I have my bits of structure to follow the contour of the outside of it. It would have been for me, it would have been far too complicated to build a complex cut system around the outside that folded down perfectly and all joined up. I have a feeling that this approach that allows me to build this 3-dimensional thing will have a similar type of outcome. Now, what I should have done is made on these back two legs longer so that they go right down to the bottom. So I'm going to have to overcome that challenge, and maybe I can use some extra cardboard and some tape to extend it. Let's press on. So hopefully this black trim I can put all the way around the outside here, and that's going to look quite nice, I think, from a piano edge point of view. So I'm going to lock that in, and I'll use some double-sided tape because I know that's going to be a lot faster than waiting for glue to dry. Okay, now to build some feet for the back. And just to help encourage this front section to stay where it should, I'm going to add a little bit of tape underneath, just to add a little bit of rigidity to that surface. And there we have it. We've got the bones, the structure of the grand piano. Okay, it's a little bit small, but it's within the constraints of what we've got. Let's add the circuit playground to it, some copper tape, and then make sure it looks great. Wind back a step. I'm going to add some black to these surfaces as well, so when I put my circuit playground down, it'll look dashing. So there we have it, the miniature grand piano ready for the circuit playground. I'm going to sit this somewhere around here so the contour sort of matches it, and run down the keys from the inputs that are capacitive enabled. So basically anything that has like an A number will work just fine for the purpose of this project. So you see here they've got like the A4, A5, A6, A7, and A0 to A3 on this side. So I'm just going to pick 3 of them and run them down just for the purpose of this exercise. Okay, so 1, 2, skip a few. We've got to the piano, the thing. Across the front here, I have my copper tape coming from my circuit playground right down to the front edge. Now, some tips for new players is that don't fix down the circuit playground until you have your copper tape where you need it to be. Crunch up your copper tape and use copper tape with a conductive adhesive so everything works a lot better in terms of electrical conductivity for projects like this. And twist it in while it's not taped down. Twist it all in so you get a nice tight bind on where that electrical contact needs to be. And just make sure that when you are preparing your copper tape, that you give yourself a little bit of extra room, and you can use the offcuts to add a little bit of extra dazzle to the project. Now, once you've got your copper tape in place, you can stick down your circuit playground, and to program it, just connect in the USB cable. And switching over to the computer, I've made some adjustments to the code. So instead of having the A button like I did before, now I have touch A7, which is the first, the leftmost button that is available on the piano. So when that is pressed, it will set all the pixels to yellow and it will play a middle G. And it'll do that for half a beat. The same for A1 and A2, except I'm going to play the tones A and B with the colors blue and pink respectively. So that way I've got a something visual and something audible happening when I interact with this project. So from here, I can simulate this on my circuit playground on the left side. I can click each of these buttons and I can witness that it works the way it should. And when I'm happy with that, I can now click download. That will download a file onto my computer. And with the circuit playground connected, it will present on the computer as a USB drive, as C play boot. And then this, you don't have to worry about the file structure here. All you have to do is click and drag the downloaded file to the circuit playground folder and then drop it on there. You'll notice the LEDs turn off and then everything just resets. So now when I press A7, I get the yellow lights, the blue lights, and the pink lights. I could hear, but I doubt you could, the tone, and that's because the speaker is quite a low volume to begin with. So a handy tip there, and now I know not all educators love having like sirens and audio in the classrooms, but this speaker isn't too loud, so you just can't make the whole classroom sound like a symphony of 8-bit music. But it's loud enough to get the job done. We can definitely increase this volume by going into music, and if we scroll down towards the bottom, we have a set volume function. So I can click and drag that, and I can just do that right at the top of my program. I'm going to click and drag and set the volume up to maximum. And now I've just made a change to my code. Now to upload that code, because there is a program running on here, you do need to press the reset button. And when the reset button is pressed and the USB cable is connected, it will re-identify as a USB drive. Click on the USB drive and then drag the file that you've downloaded and drop it onto the Circuit Playground. Now it's ready to rumble. So that new code is on there. And so now when I press A7, A1 and A2, I've got this all working. Now I can test my copper tape. And now I can explore this and have a bit more fun. Let's play the first couple of tones to Hot Cross Buns. Great, I got a bit of a double tap there. It might be that connector isn't quite where it needs to be. Another tip with copper tape is that if you do change the capacitive circuit, is to reset your Circuit Playground. So press it once to enter programming mode with all these green LEDs, and press it again to begin running the program that is on the Circuit Playground. Now, when it starts, it actually relearns what the capacitive values are for each of the connected things. Because if that changes, it can make the project a bit intermittent if you were to extend this copper tape out and change the electrical properties or the capacitive properties of that circuit. But that's it. You know, here we could add dazzle all day long from this point, and I could add all different colored bits and pieces to this project. Really sauce it up with some creativity. But that's the code, build, and dazzle part of this project. So the last part of the journey is share. Teams can get up the front, explain what they've created, what it's called, how it works, the challenges along the way. For example, with this project, I ran into challenges in the design in going from a 2-dimensional to a 3-dimensional project. I forgot to add the legs on the back, so I've had to add those separately. As an educator, you're probably privy to each of these little constraints and challenges, and you might be able to help provoke these questions during this share experience to introduce the different complexities of what happened. And of course, what they would do if they had more time. So other features that they would be able to remix into this and make it different or adjust the settings to make it behave differently. Now, the remix part of this is a bit of a handy tool if you do have somebody that is just powered through this journey, is to introduce sensible remix challenges that would really get that team thinking about how they could implement this or take it to the next level. And always keep that card in your back pocket so that you can help keep everybody on the same timeline and go through that shared journey together. Well, that's it. That's the Maker Invention Cycle. That's what we do when we run our workshops. And I hope you've got something out of it. I know it's a very heartfelt, casual approach to education, but the recipe that is the cycle, I hope that it's of value to one or two people. If it is, please let me know. Shoot us an email to support@coreelectronics.com.au. You can find that on our Contact Us page. And if you have any questions or you want some ideas, please get in touch. Happy to help.